In this video, we'll be talking about the definition of an ellipse and the graphical geometrical definition of how it is created and what are all the pieces of it. So an ellipse is a set of points in a plane, the sum of whose distances from two fixed points, those fixed points being the foci, is a positive constant. Now this definition seems really off-key, especially compared to that of the parabola definition. So let's go ahead and talk about the 2 points that we have. So we have 2 points, those are considered the foci. Again, I'm going to go ahead and label them as x's this time around. If I were to draw an ellipse around those 2 points, again, the center being somewhere right about here, we've got something that looks something like this. Now, what's important to understand is, again, this might not be drawn accurately, but what does happen is that the distance from this point somewhere up to that ellipse, the distance from this point up to that ellipse, those 2 values may be different. However, those 2 values added together will be equal to another value. I'm going to call that value C in this particular case. This is probably bad notation, but I'm going to go ahead and work with it regardless. If I go ahead and pick a different point somewhere on the ellipse, let's pick that point over there, and I draw the lines directly from the foci to that point, this will be, let's call this E and F. If I add E and F together, we will also get C. So the idea is that the 2 points will always create the exact same constant. So the sum of the distance from the foci to the edge of the ellipse will always be the same value. That's the definition of how an ellipse is defined. Now, to identify the information and graph it, we're looking at first the vertices, the foci, the center, the major and minor axes. In terms of drawing a few pairs of lines that connect the foci to the point, we've done that piece. That piece is right here. I'm going to draw a separate graph to identify the foci, vertices, and everything else. Now, in most cases when graphing an ellipse or manipulating an ellipse, we're going to start with the center. So I'm going to call that piece right there the center. Next, I'm going to go ahead and identify foci. Now, the foci will always be built in either a horizontal way or a vertical way. The foci will always be in the vein of graph such that they are in the longest side of the ellipse. So if I draw a foci right about here, that means my second foci should be equidistant from that right about here. So again, those distances should be exactly the same here and here. Now the fact that I've drawn the foci vertically means that my ellipse should transpire around it in something like that nature. That might be a little bit off, but that's okay. The general idea is there. Now, the foci are here and here. Those are my foci. My vertices will be here and here. So now make note that the difference between an ellipse and a parabola is that an ellipse has 2 foci now. 2 foci now. It also has 2 vertices now. And so these 2 points here are the vertices. Those vertices are the values at the end of the major axes. So the major axes will pass from one vertice through the foci, through the center, through the other foci, to the other point. That line right there is called the major axis. The major axis, again, connects one point to the other. So what we will generally be asked to find is what is the length of that major axis. Now, again, you'll notice that the major axis includes both foci. It also includes both vertices. On the perpendicular sense, we have this right here. We can identify this point and this point. I'm going to put little circles around them, but they're not vertices. I refer to them generally as off vertices. They may have other more definitive names, but they're very specific points on the ellipse, but they're not vertices. Now this line right here, that line is the minor axis, and again, you might be asked to find the length of the minor axis. But that identifies all the major pieces of an ellipse. So again, you have your foci, which are 2 points in the middle of the ellipse in some way. You have your center, which is directly in the middle of the ellipse. You have your vertices that are at the ends of the major axes. Again, the major axis passes through both the vertices as well as the foci. And then you have your minor axis, which cuts perpendicular to the major axis, again, not including the vertices or the foci. So these are all the minor pieces of the ellipse that are important that you might be asked. So in the next video we'll discuss the equation and how all those pieces can be found by utilizing that equation, or how we can utilize pieces of information we were given to find the equation of that ellipse.